Ahoy there, we are jumping right into 1.3, which is solving equations with variables on both sides of the equal sign. So basically it's the same as what you did before. To solve, you're going to simplify one or both sides, and then use inverse operations to collect the variable terms on one side and isolate the variable. So it's what you did before, but sometimes you got to move the variables to the same side and then solve it. Let's go through some examples. All right, so the first one, we have x on both sides. So we have 10 minus 4x equals negative 9x. What's a good first step if you want to move the x so that it's all on the right-hand side of the equal sign? Yeah, so what I would do, well, first rewrite the equation, add 4x to each side, and then you're just left with 10 on the left. The 4x here is gone. Negative 9x plus 4x is negative 5x. So then you would divide by negative 5, and you'll find out that x equals negative 2, which again, you can plug in to the original expression or original equation to see if that works. You have to plug in that negative 2 to both these x's. So when you plug it in here, you get 10 minus 4 times negative 2, which is like 10 plus 8. And then here, negative 9 times negative 2 is 18. And you get 18 equals 18. That works. That's the correct answer. Okay, here's another example. This one looks super ugly. First thing I would suggest doing is anytime you have something like this, distribute. So get rid of the parentheses by distributing. So what do you end up with here on the left when you distribute? Okay, so when you distribute the 3, you get 9x minus 12. So you're distributing the 3 to both of those, you get 9x minus 12. Here, when you distribute the 4th, that's like dividing each of these by 4. So you end up with 8x plus 14. Now, to solve that, it doesn't matter whether you move the 9 or move the 8. What I would suggest is I like to avoid negative numbers. So if it were me, and they're actually doing the numbers first. Wise move. If it were me, I'd subtract the 8x on each side, which is what they're doing here, so that you don't have to deal with negative numbers. So here, they added 12 and then subtracted 8x. You find out that 1x equals 26, which again, you should plug in and check to see if it works. You'd have to plug it in here and here. I'm not going to do that for sake of time. If you have questions about this, ask me as you're working through the problems on Big Ideas. Okay, and then you also have some story problems. So take a minute, look this over, and try to write an equation that matches this story. This one's kind of a tricky one. Okay, so we have, hopefully you understood the problem, identify all the important information. So the distance formula is useful, which is distance equals rate times time. So we know that the distance upstream is equal to the distance downstream. So the rate times time upstream has to be the same as the rate times time downstream. So the time upstream is 4 hours. I'll move myself here. There we go. So we have the speed upstream times 4 hours has to equal the speed downstream, which is 3 miles per hour more than the speed upstream. That's why they have this x plus 3 here. And then the time downstream is only 2.8 hours. So hopefully you got some sort of equation like this. So 4x, 4 times the speed upstream, has to equal 2.8 times x plus 3, because this x plus 3 is the speed downstream. It's 3 miles per hour faster. So x stands for the speed upstream, which is what we're looking for. All right, so distributive property is next to solve this. So you distribute the 2.8 and you get this right here. What's a good next step? Subtracting 2.8x on each side is a good next step. That will leave you with 1.2x equaling 8.4. Then you divide to find out that x equals 7, which means that the speed upstream is 7 miles per hour. If you need to find the miles upstream, they did that for 4 hours. So you go 7 miles per hour times 4 hours. It's 28 miles each way on the trip, upstream or downstream. Okay, and you should also verify that the answer makes sense. So take a look at that and see if you agree with their description of why this answer does make sense. Okay, you can also verify it by doing this, showing that the distance is the same, both upstream and down. All right, so that's solving. We will have 2 special cases. So sometimes when you solve equations, there's actually no solution, like it doesn't work. And sometimes when you solve equations, there are infinitely many solutions. Oh, that's the phone. I gotta wait on that. Okay, It's Mr. Page. He's calling about fantasy football. I got to make a video right now, man. Okay. So we're going to go through those examples when you have infinitely many solutions and when you don't have any solutions at all. So for this first one, we're just going to talk about A right now. We have 3 parentheses 5x plus 2 in parentheses equals 15x. So do this on scratch paper right now and see what happens. We'll go through it now. Okay, so first you distribute and get 15x plus 6 equals 15x. Now, if you subtract 15x from each side, you end up getting 6 equals 0. Well, 6 doesn't equal 0. So if this ever happens where you end up with a number that really doesn't equal another number, what that means is there is no solution. This thing is not true. Therefore, there's no number for x. You can sit there for 1,000 years, try different numbers for x. There's no number you can plug in for x that makes this work. So there is no solution to this equation right here. Okay, so now let's go through this one. So try to work this one out on scratch paper and see what happens. All right, so here, again, distribute. Don't forget to distribute this minus 2 to this positive 1, making it negative 8y minus 2 here, and negative 8y minus 2 over here. Oh, look, those are the same equation or same expression on each side of the equation. Add 8y to each side, and you get negative 2 equals negative 2. In this case, this is always true. All right, what this means is there are infinitely many solutions to this equation. You can plug in infinitely many different values for y, and this will be true. So in this case, when you end up with, like, if you get 9 equals 9, then it means there are infinitely many solutions. Okay, so that's our weird cases. Sometimes you'll have no solution if you get like 5 equals 3. Sometimes you'll have infinitely many solutions. All right, if you have questions about this, ask me, Flipgrid me, email me, get some help from Mr. Brood. Good luck as you're working on 1.3, and I'll see you in class. All right.